Switzerland just released a local AI with open weights, open training data, image and audio understanding, and a massive context window. But fully open does not mean completely frictionless. Apertus 1.5 arrives in an 8 billion version aimed at practical deployment and a 70 billion version for much heavier machines. Both accept text, images and audio. The smaller model received 4 trillion additional multimodal training tokens. The larger model received 2 trillion. This is continued pre-training of Apertus 1.0, not a clean sheet model. This is the official Swiss AI model card. It lists the weights, the A-patch-E license, the supported inputs, and the instructions required to serve the model yourself. At a glance, the release offers 2 model sizes, 3 input modalities, thinking mode, tool use, and an official maximum context of 262,144 tokens. That context ceiling is 262,144 tokens, 4 times the default context listed for the original Apertus release. The headline is not really the parameter count, it is the word open. Most so-called open models expose their weights. Apertus says it exposes the entire development stack. The official card describes this as open weights, open data, open values, and full training details. That gives researchers something much closer to a reproducible system than a weight file alone. Think of openness as 4 separate doors. Downloading the parameters opens only one. Apertus is trying to open the data, recipe, and governance doors as well. That distinction matters. Open weights let you run and modify a finished artifact. Open data and recipes let outsiders examine how that artifact was built and challenge its assumptions. The data story is unusually deliberate. Swiss AI says it used fully open training data and attempted to respect publisher opt-outs, including retroactive opt-outs where possible. That does not automatically make every answer accurate, unbiased, or safe. It makes the ingredients easier to inspect. Transparency and model quality are related questions, not the same question. Apertus is also massively multilingual. The official project FAQ says the family was trained on more than 1,800 languages, while warning that full conversational quality currently covers only a few dozen. Version 1.5 adds native image and audio understanding. You can combine those inputs with text, but the output remains text. It does not generate pictures, speech, or video. The official documentation is explicit about that boundary. Apertus accepts interleaved text, images, and audio, then generates a text response. In practice, that creates a private analysis pipeline. Feed it a document, image or audio clip, ask a question, and receive text without sending the source to a hosted model provider. That sounds ideal for private document search, local transcription analysis, image question answering, and research archives. But those are use cases to test, not proof that Apertus beats every specialist model. There is another useful option, thinking mode. The model can reason before answering, but the current instructions warn that tool calling is not supported while thinking mode is enabled. That trade-off matters for agents. A benchmark can advertise reasoning and tool use on the same feature list, while your actual deployment still has to select the mode that fits the task. Now for the word local. The 8 billion release is the realistic starting point. The 70 billion release is still local if you own the hardware, but it is not an ordinary laptop model. The model page already links quantized builds for llama.cpp, O.D.I.N, and LM Studio. Quantization reduces the memory footprint by storing lower precision weights, with some quality trade-off. For a first local test, choose the 8 billion model, use a suitable quantization, and keep the context modest. A 262,000 token maximum is not a free default. Long context consumes additional memory through the key value cache. So the same model can fit comfortably at a short context and fail when you push the context slider to its advertised maximum. The official Quick Start currently uses a modified VELLM build and a dedicated Transformers branch while upstream support is still being integrated. This is a fresh release, not yet a perfectly boring one-click model everywhere. So, if your desktop app cannot load Apertus today, that does not prove the model is fake or unusable. It may simply mean the runtime has not merged support for this architecture yet. And now the first catch. The repository is publicly visible, but the files are gated behind an agreement that shares your Hugging Face username and email with the model authors. The gate is stated directly on the official page. You must agree to share contact information before accessing the model files. That does not secretly close the weights. The repository lists patch E 2.0 and accepted users can download and run them. But it does add identity and policy friction to a release marketed as fully open. The second catch is evidence. The card says performance is comparable to models of similar size, but it also says the detailed technical report, benchmark results, and intermediate checkpoints will arrive in the coming weeks. That means this launch is easy to evaluate for openness and architecture, but harder to rank confidently for intelligence. Until the full report lands, any winner graphic would be premature. And the third catch is maturity. Modified runtime branches, a download agreement, and an unfinished technical report are normal for a new model, but they matter if you need dependable production deployment today. If you want to judge Apertus fairly, do not begin with one trivia prompt. Test the reasons this release exists: privacy, multilingual work, multimodal input, and inspectability. First, give the 8 billion model a document you are not willing to upload to a cloud chatbot. Check whether it follows instructions, cites the supplied material, and stays within the document. Second, use an image and an audio clip from the same event. Ask what each source proves, where they disagree, and what remains uncertain. That tests the new multimodal path instead of ordinary chat. Third, repeat one task in several languages and compare the substance, not just grammatical fluency. A multilingual label matters only when the reasoning survives the language switch. Finally, measure the boring things: load time, memory use, tokens per second, and how much context you can actually sustain. Local AI is a hardware result as much as a model result. So is Apertus 1.5 the best local model? There is not enough independent evidence to say that. Is it one of the most interesting open releases? Absolutely. Its strongest argument is not one benchmark bar. It is the attempt to make the weights, data, recipes, and policy inspectable while still producing a model people can run under their own control. The 8 billion model is the version most local users should watch. The 70 billion model demonstrates the ambition, but the smaller release will decide whether this openness becomes useful outside research clusters. We will revisit Apertus when the full technical report lands and test the quantized 8 billion model on real local hardware. That is when fully open becomes measurable, not just marketable. Would you run Apertus locally, or does the download gate undermine the fully open claim? Tell us which test you want first and subscribe for the measured follow-up.